Hello, my name is Diana Fisher. I was a secondary school mathematics and science teacher for most of my career. In the last 2 decades of my career, I used modeling of dynamic feedback systems, that is, system dynamics, in my classes, and it had a large impact on my classes and on me as a teacher and as a person. I also want to state that the Systems Thinking Association of Türkiye is a world leader in bringing the study of dynamic feedback systems using system dynamics to the pre-college education system. In many industries and countries, some of the most in-demand jobs didn't even exist 5 or 10 years ago, and the pace of change will only accelerate. New categories of jobs will emerge, partly or wholly displacing others, says the World Economic Forum in its report, The Future of Jobs. The skill sets required in both old and new occupations will change in most industries and transform how and where people work. Many of these advancements involve complex, dynamic feedback systems. This slide shows a quick list of the characteristics of a dynamic feedback system. A system contains elements that are interconnected and work together to perform a specific task. There is not enough time to go through this whole list now, but I would like to highlight some important ones. Dynamic feedback systems contain feedback, so we need to help our students understand what it is and why it is important. When humans try to improve system behavior, there are often unintended consequences that can create new problems. There are often multiple ways to improve system behavior. And of course, these systems change over time. They are dynamic. Let's look at a quick example of a dynamic feedback system. In this system, the elements are the lynx, a predator that eats rabbits, and the rabbits eat vegetation in the environment. All of these entities are connected. Well, they are more than connected. There are feedbacks between the elements. If there are plenty of rabbits, the lynx population will grow, which will reduce the rabbit population, which will, in turn, reduce the lynx population. Similarly, if the rabbit population grows too large, they may reduce the vegetation to the point that it cannot regenerate fast enough to feed the quickly growing rabbit population, etc. Then, with fewer rabbits, maybe some of the lynx find other sources of food that is not so acceptable to local farmers or ranchers. Upset farmers and ranchers ask the government environment department to allow them to kill some lynx. This fixes the problem, or so they think. With fewer lynx, all of a sudden, the rabbit population starts to grow. Of course, lots of extra rabbits reduces the vegetation available for human enjoyment and for rabbit food. Trying to control the rabbit population might be achieved by bringing in another rabbit predator, provided it won't also kill any livestock. So the rabbit population may become more stable, which would allow the environment to recover. This system is more complicated than the original system and represents a slightly better solution than just killing lynx, but it also may create another larger oscillation in populations if the lynx population cannot sustain itself on the smaller rabbit population. In the study of systems, you will often hear two phrases used somewhat interchangeably. I would like to clarify what I mean when I use these phrases, systems thinking and system dynamics. Systems thinking is a process of looking at systemic problems holistically. It explores the interdependencies among the elements of the system, focusing on the feedback loop structure of the system, because the structure, the interconnections of the system, determines the behavior of the system over time. It uses mental analysis to help determine how the system might behave. System dynamics does the same thing, but it relies on building computer simulations to test one's mental model about how a system works and why it produces its behavior. Forrester says we must test our mental models because just thinking about why a system behaves the way it does is not enough. We could be wrong. The computer will actually show us whether our ideas actually do produce the behavior we expect. Without using the computer, we have no idea whether the strategies and policies we recommend will actually address the problem or whether they will produce unintended consequences and more troublesome behavior. Donella Meadows was a brilliant scientist and someone who applied her knowledge of system dynamics to numerous real-world problems. She was able to communicate those problems and solutions elegantly. Later in her life, she wrote a newspaper column called The Global Citizen, which contains many of her insights. Many of her articles are online. Donella Meadows said, if we want to bring about the thoroughgoing restructuring of systems that is necessary to solve the world's gravest problems, poverty, pollution, and war, the first step is thinking differently. Everyone thinking differently. Those of us who have studied and used system dynamics in our work will tell you that this method of analysis has changed how we think. It is powerful, exciting, and an important way to understand the world. There are so many examples of dynamic feedback systems in the world that learning how to analyze them better would be a skill that would be valuable for years. And there are hundreds more complex systems across almost every discipline. As we try to reduce the problem behavior in some of these systems, we need to develop public policies that actually have a chance of working. We can do that more effectively if we can test those policies in advance, like using a flight simulator. That is one of the major benefits of teaching students to build models of dynamic feedback systems. We can send them to their next level of learning armed with powerful tools. System dynamics is a method for analyzing the forces behind systemic problems in the hopes of recommending and testing policies that may help reduce the problems. One must start with a systemic problem that is dynamic. Then the stakeholder and the modeler identify some major components in the system and research past behavior over time for those major components. The next step is to start to construct a model containing the major components and the feedback that produces the problematic behavior. This model is tested, analyzing the feedback. Then the stakeholder and modeler come up with potential policies they think might modify the model behavior to produce a more desirable outcome. Those policies are tested on the model to determine whether they might actually work as desired. Ideally, an optimal policy is identified and implemented. Teaching systems thinking and system dynamics to students ages 5 to 10. As you might guess, the biggest resource to use for students at these early ages is stories. There are wonderful books that include many important systems thinking concepts, including some written by Turkish teachers. Other systems thinking and system dynamics materials for this age can be found at the Creative Learning Exchange, the Waters Center for Systems Thinking, and on Linda Booth Sweeney's website. Some of the major systems thinking and system dynamics tools for this age are behavior over time graphs, BOTGs. See the example shown. Notice there are no numbers on the axes, but descriptions or pictures are given on the axes to help the student create the graph. Causal links and simple stock flow diagrams, iceberg diagram, causal loop diagrams, ladder of inference are all used for this age group. Pre-designed stock flow simulations for students are also used for experimentation. Systems thinking lessons from Turkey will be presented next. at the 2018 International System Dynamics Conference in Reykjavik, Iceland. Some educators from Türkiye presented work done by 4, 5, and 6-year-olds involving an ecology problem. The problem about a frog pond near houses was written as a story and authored by one of the educators. The frogs made lots of noise at night, which bothered the people. Notice that the student work analyzing the story contains behavior over time graphs, simple stock flow diagrams, and ladder of inference diagrams, and feedback loops. Here, attendance behavior over time graphs are drawn by students in a kindergarten class. Now we'll talk about teaching systems thinking and system dynamics in grades 6 through 8. Stories are still very powerful for this age group, but I have decided to identify some books of lessons that are worth considering at this stage. The Creative Learning Exchange has numerous books of lessons for reasonable prices. Linda Booth Sweeney wrote the Systems Thinking Playbook with Dennis Meadows. It contains physical activities that help students develop systems thinking concepts. The Habits of a Systems Thinker, created and sold by the Waters Center for Systems Thinking, can be used to support developing systems thinking concepts. The tools that support systems thinking at this age level are mostly the same ones for the early elementary school students, but add to that the use of connection circles, which is explained in the Shape of Change book, and having more students using and creating simulations using Stella Online. Here are some amazing middle school lessons used in Türkiye. Grade 8 lesson on sustainability is shown here. This pre-created simulation compares global wealth and emissions for many world countries. This simulation contains multiple lessons. This grade 6 set of lessons helps students understand how the circulation works in the human body and how it cycles. There is a written lesson guide for teachers. These are the disciplines in the United States where system dynamics has been used in the secondary school classroom in some schools. At the secondary school level, access to stock flow modeling software is extremely important, especially for math and science. Only these 4 icons are used to build models. The rectangle, the stock, increases or decreases in value over time and is the main variable whose values we want to graph. The stock value is only changed by flows. If the flow arrow is pointing toward the stock, it increases the value of the stock. If the flow arrow is pointing away from the stock, it decreases the value of the stock. Converters will usually hold constant values. Connectors will link model components, sending values between components. So this is what a basic population stock flow diagram would look like. Births are calculated by multiplying the current value of the population by the birth fraction. Those births are sent to the population stock and increase its value. Similarly, deaths are calculated by multiplying the current value of the population by the death fraction. Those deaths are removed from the population stock and decrease its value. Stories, especially news stories, provide rich resources for systems thinking and system dynamics concepts for this age group. For those educators who want to start using more system dynamics simulation work with students, first identify those difficult dynamic concepts in your curriculum which might be amenable to modeling. This way, you will not be adding more lessons to your already full curriculum. You will be replacing older lessons with better lessons. There are a couple of books of lessons from IC Systems that might be helpful. One book contains lessons for teaching a 9-month system dynamics modeling course at the secondary school level. Consider some suggestions for lessons. It is possible to use some pre-made simulations. Students could be asked to build a small model using a guided model building lesson in class, or asked to add structure to a working model. Students could create, in groups of 2, a small simulation model from a news article. The teacher will have to debug students' broken models, however. Again, the tools for this age group include some of the tools from the previous group of students. You can see a sample modeling screen for the free web-based Stella Online software, and the URL indicates where to locate this free software. If I were to recommend one excellent book for middle school and high school math or science teachers who want to get started learning to use system dynamics modeling in their classes, I suggest you obtain a copy of the Shape of Change book sold by the Creative Learning Exchange. Many lessons can be downloaded for free on their website. The reason I like this book so much is that each lesson in the book starts with a physical activity to help students understand the dynamic behavior of the problem presented. Many lessons require the student to collect data, and the authors provide a list of questions and suggested answers to help students develop their systems thinking skills. System dynamics can help all students understand dynamic feedback systems better and gain important insight into making the world a better place. Before I end this presentation, I want to show you that students can do amazing work when they understand system dynamics modeling. My year-long secondary school system dynamics course had students ages 15 to 18 in the same class. The model I will show you was created by an 18-year-old student in that course. In the final 10 weeks of that course, students chose their own system problem they wanted to model, researched the problem, and created a working model. In 2007, when the United States was experiencing an oil crisis, this student observed that many people were trying unsuccessfully to buy hybrid cars. This was his idea of why that problem happened. It actually is broken into 3 segments. There is a hybrid car segment at the top. I'll go back. Hybrid production, hybrid inventory, and active hybrid vehicles. There's a factory capacity section, which was a limiting factor on being able to produce enough cars. And then there was a backlog of orders and a perceived backlog indicating that you weren't going to get a car very soon, even if you ordered one. Now I will show you some resources available for obtaining the Stella software and books of lessons, etc. in the United States. Most importantly, all K-12 school systems globally can apply for a free site license of the Stella Professional Online Modeling Software. It does not have the restrictions of the regular Stella Online software, but it is still web-based. This slide shows the person to contact at IC Systems to request this site license. IC Systems also has a couple of books of lessons for teaching system dynamics in secondary and undergraduate math classes, and also for teaching a 9-month system dynamics modeling course, as well as many free simulations, not pre-reviewed, so you have to check who the author is, that are available at exchange.icsystems.com. The Creative Learning Exchange has many books of system dynamics lessons for teachers of primary through secondary school students. CC Modeling Systems, my website, gives access to many stock flow diagrams of original models created by secondary school students and their papers. Also, there are some free lessons that can be downloaded. Moreover, the System Dynamics Society has a pre-college web page that contains recordings of all of our educational webinars and special interest group meetings. It contains some free lessons, books, and models, with more to come. Many of these resources are translations from the work done by the Systems Thinking Association in Türkiye education members, as most of the System Dynamics Society pre-college leadership team come from Türkiye. There is a free model builder software that helps teachers and students create stock flow diagrams. There is another free system dynamics modeling software called Sage Modeler with some free lessons and models that middle school and secondary school teachers may find useful. The Systems Thinking Association in Türkiye provides many resources for their educators. There is an entire website in Turkish for educators that contains many videos, lessons, models, and online courses. And an important free book written by Emre Göktepe and the Systems Thinking Association of Türkiye. As you already know, there is an annual Systems Thinking Symposium for educators in Türkiye. The Systems Thinking Association of Türkiye continues to add resources regularly. Thank you very much for your attention.